Welcome, and we are going to talk about some function properties. And the first one has to deal with this notion of increasing and decreasing. And so, just to begin that discussion, here's a function and its graph, right? And I'm just curious, how would you describe this to a person who maybe can't see this well, and or maybe they have their eyes closed and they're asked to, imagine what this graph looks like? What sort of language would you use? Well, if it was me, I would say, okay, well, when I look at this function, we have the function, uh, it's approximately on a domain of -2 to 2. Okay, that's first thing. And then I would say, as I go from left to right, it falls vertically. And then at -1, it sort of bottoms out. And then from when x is -1, after that, it rises vertically and then sort of tops out at the origin. So sort of a U shape top of a hill at the origin, and then go down thereafter as I go to the right, forming another valley. And that valley bottoms out at when x is 1, and then after 1, it sort of rises. And so the language of rising and falling vertically, we can maybe use some different language there. And the language that mathematicians use is this notion of increasing and decreasing. So you can see the formal definition. It's a little technical. And so we're talking about an open interval I, and so the idea is that if you have, so if you're looking at the real number line, here's 0, maybe your region I is something like this, from A to B. I don't know what that is, what those numbers are precisely, but I would be this entire thing in there. It's just some interval piece of the real line, okay? And then what we would see is that we would call a function increasing if f of x1, again, this is a y value, is a y value corresponding to x1, and maybe a is x1, or maybe not, I don't know. And then f of x2, again, that's another y value, but we would see that the first y is less than the second y, assuming that these x's are in progression in numerical order. Okay. Informally, what this would look like is if you can imagine a graph, we would see a function where, okay, here's say x1 and here's x2, and maybe this is, interval A to B, something like that. We would see, okay, as we progress from right to left, it is going upwards. And so it has a positive slope. Another thing that we can say is that if we think about the average or even just rate of change, and I'll put average kind of in parentheses here, average or instantaneous rate of change on this interval, if we look at, change in y over change in x, right, that idea, if we calculated the slope, right, the slope would be positive, okay? So we have positive slope, we have positive rate of change, okay? Decreasing, the notion of that is as you go from right to left, you are falling. Or sorry, left to right, you are falling. And again, this is the y value. So the previous y value corresponding to the point on the left side of the interval is larger than y value on the right side. And so again, informally, if we imagine a graph, and this time maybe here's x1 and x2, but again, these two fall within a general interval a to b, what we would see is at any place in this interval, we would see the function falling, okay, as we progress from right to left. So again, change in y over change in x is negative, and so the, again, rate of change, average or instantaneous, would be negative. Okay, and the last thing we have to look at and consider is when the function is constant. And constant just means the y values are the same on that interval. Okay, and so again, if we just think about a general x1 and x2 on an interval a to b, x and 1 and x2 are just general things in the interval. But what we would see is it would be flat, okay, just horizontal, zero slope, okay? And so in this case, the rate of change, average or instantaneous, would just be 0, okay? And so I kind of been talking about this, but think about the average and instantaneous rate of change when these functions are increasing, decreasing, and constant. And so just to now maybe use a little bit different language with this function that we started out with, we want to identify all intervals of increase, decrease, and constant behavior. So I'm just going to make note of that. Increase, decrease, and constant behavior. Okay, and intervals, right? When we talk about that, that requires interval notation. So that uses x's, and then the brackets versus parentheses stuff. So make sure that if you're a little sticky on that, make sure to review that. Okay, so now I'm just going to kind of inspect this. I'm going to do increasing in yellow. So I'm thinking as I move left to right, where is the function? Where are the y values increasing? So I'm going left to right, and here I see the function values as I move right, I am falling. This is decreasing. Okay, so I can't highlight that in yellow, but I can highlight it here because as I go from left to right, I am rising. And same thing over here. Okay, so now I just need to represent those in interval notation. And so I'm going to say this is -1. I start at -1 and I go to 0. And by default, we use parentheses for intervals of increase and decrease because we can't say a point is increasing or decreasing. Okay, so that's why you see parentheses, brackets. It really doesn't matter. You could include brackets if it's just a little weird to say increasing or decreasing at a point. And then over here, this would be 1 to infinity. And I always get the question, do you need what sort of thing do you put in the middle here? Do you do a comma? Do you do a union? Typically, when we write intervals, we just kind of say, like we list them, right? It's not a bad thing to write a union, but generally we just do a comma. Okay. All right, next, decrease. Okay, where am I falling vertically? Well, that's this piece of the function here, right? And here, as I go from left to right, the y values are going down. Okay, so representing these in interval notation, this first piece would be minus infinity to -1, and then the second piece would be 0 to 1. Okay, and then again, I just do a comma in between. Okay, and then where is it constant? Where is it flat? And I'm just going to say there aren't any, so you can say none. This is technically called the empty set. To communicate nothing. So you could do like that too, or you could just write none. Any one of those responses is fine. Okay, so be aware of intervals of increase, decrease, and constant behavior. They will be showing up a lot.